Good evening to all of you. Hello, I am Saikat Giri, your chemistry educator. Today we are going to start one of the less discussed topic in classes, that is Bend's rule and Drago's rule. This concept related to hybridization and very important in the terms of JEE mains and all national exams, even in state exams. Okay, let's check out what is Bend's rule and how it is being considered. So, we are going to take for sp3d hybridization, mainly discussed for sp3d hybridization. So, for sp3d hybridization, what is Bend's rule? It is more electronegative atom prefers to stay at axial position, whereas lone pairs, or we can say less electronegative atoms, prefer to stay at equatorial position, denoted by E. Axial position denoted by A. So, let us take an example to understand this concept better. We are taking ClF3. So, in case of ClF3, we know it is less in number, so chlorine is our central atom. So, there may be two types of structures we can consider. One, chlorine. As sp3 dehybridization, we can say this is TBP or trigonal bipyramidal geometry. So this is our TBP geometry, trigonal bipyramidal. Why it is named as bipyramid? Because the structure is like this. This is one pyramid and another pyramid can be drawn with respect to this. It can be drawn like this. So this is named as trigonal bipyramidal. Now, for fluorine, what may be the position where we can step it? Now in this case, fluorine can be placed here, in this position, in this position. And in these 2 points, we can draw 2 lone pairs, one lone pair, another lone pair. Someone may think, no, I am not going to do like this. I am going to draw the structure in this manner. Here one lone pair, here another lone pair, and fluorine will be placed in these positions. Someone can do like this. From Bend's rule we came to know that this form, this is wrong and this is correct representation. Why this is correct representation? Because fluorine is a more electronegative atom. From VBT concept we know that more electronegative atom will try to locate itself as far as possible from the central atom. So chlorine is trying to locating itself as far as possible from the central atom, means chlorine itself. So if it is present in these positions, it will be more stable. So in this case we can say this is the correct representation and this is wrong representation for Bend's rule. Now if I want to represent sp3d in a practical shape in a diagram, now you can see that in sp3d, in this diagram we can draw it like 1, 2 and another 1, 3. This is sp3d representation. In this case, this is PD and this is PD. These are axial positions. These three are equatorial positions. This is equal to sp2 plus PD. These are 2 PD and this is sp2 this is sp2, this is sp2. If someone want to think in this way also, you can consider, forget about these two lobes. So in this format you can say this is a trigonal planar geometry. This is TBP, trigonal bipyramidal geometry. So these two lobes creates two pyramids and makes it trigonal bipyramidal. So you can say all these three positions are sp2 and these two positions are p and d. Bend's rule for sp3d hybridization with respect to lone pairs, how can I explain? Let us consider I am taking bond pair, lone pair, I am checking the shape of the molecule, and with respect to that, examples. So bond pair, lone pair, shapes and examples. We know that if we are drawing sp3d, in that case, how many bonds are required? 1, 2, 3, 4, 5 bonds are required. So if bond pair is 5 and a lone pair is 0, then in this case shape is equals to geometry and it is sp3d. Hybridization always sp3d we are considering. It is trigonal bipyramidal shape TBP, and the most famous example for this is PCl5. How PCl5 can be drawn? You can see for PCl5 central atom is phosphorus. It is connected to chlorines 1, 2, 3, 4, 5. So here shape and geometry both are TBP, exactly the same. Next, say if you are taking, there are 4 bond pairs and 1 lone pair. 4 bond pairs and 1 lone pair. How it can be drawn? So here, in this case we can check. There is 1 lone pair and 1, 2, 3 and 4 bond pairs are there. This type of structure is named as seesaw. It looks like a teeth. That's why it is named as seesaw. What can be the example? We can take SF4. Let's draw SF4. For SF4, it can be drawn central atom sulfur. We are going to draw fluorine atoms. You can draw above or below, wherever you want, and 1 lone pair. So this is SF4. This is known as seesaw. But drawing the exact structure would be little bit different. In many books we follow this method to draw the structure. This. And this is more appropriate. We cannot draw the previous one. Why? Because in that case most electronegative atom will not be in axial positions. Here also we can say that there are 2 possibilities, but this possibility will be better for seesaw structure. Next case, if we take 3 bond pair, needed 2 lone pair. 2 lone pair is coming. In that case, what will be the structure? You can check. These positions are fixed. This is not going to change. So 2 lone pair is going to be in these 2 sides. Example, if you want to take, we can take ClF3. So in case of ClF3, if you want to draw ClF3, chlorine central atom and 3F we are going to take ClF3. This structure is named as bent T-shaped. This is like English letter T. So this is, we can say, T-shaped or bent T-shaped for ClF3. If there is 2 bond pair and 3 lone pair, what is going to happen in that case? It is going to be a linear molecule. Example, I can take I3 minus, ICl2 minus, I can take XCF2. In all the cases, it is going to be sp3d hybridized and structure going to be linear. let's draw for I3 minus. I3 minus. In this case, iodine central atom, two atoms need to be placed in axial positions. So you can draw it like this: one lone pair, two lone pair, and three lone pair. So this is all about lone pairs and how hybridization structures are varying. Rest all the cases, only in the first case shape equal to geometry in this case. Rest all the cases, in all cases geometry is TBP. All are TBP. All whatever example we have taken, all are TBP. Their geometry is TBP, but shape is different. One is seesaw, bent T, and linear. I think you have understood this part of Bend's rule. According to this rule, we can say that the orbital occupying more space will have more percent S character. So the orbital having or occupying more space will have more percent S character. Now how can we explain that? Let's check. And this occupancy, occupying more space, this occupancy with respect to central atom is decided. So this occupancy is with respect to central atom. Let us take one example for SF4 molecule. We already have discussed that SF4 has seesaw structure, and we can say the shape is seesaw, TBP geometry, and hybridization is sp3d. So in general, if you are taking any compound, then also same variation we can see. See, this is our axial positions. We can mark it as A. This positions is our equatorial positions E. We can check here angle is 90 degree. So space is less. Here angle is 120 degree. So more space. So this is the logic for less space or more space in a molecule. Let us take SF4, the example I have taken. So sulfur, 2 fluorine are there, and rest 2 fluorines are in this position. Here lone pair is present. We can draw like this, or better to draw like this, SF4 molecules. So in this case lone pair is present. How can we say that in these cases, in axial positions, according to the rule, orbital occupying more space, here axial is occupying, or we can see the angle, axial is occupying less space, but equatorial, it is occupying more space. So in this case, for F molecules, they are in axial position, they are in 90 degree angle, so occupying less space, but these three positions, it is occupying more space. Now let's check. If we take XeF5 minus, xenon atomic number 8, 5 is 5 fluorine, it is monovalent, so plus 5, minus is there, so plus 1 divided by 2. Which rule I am applying? This is actually one extension of VBT, or you can say this is VBT rule. What is that? Xenon is the central atom, valency 8, so valency of central atom plus number of monovalent atom, add if negative charge, subtract if positive charge, so plus 1 is added, divided by 2. So this is 14 divided by 2, it is 7. So 7 means sp3d3, pentagonal bipyramidal geometry, PBP. Now let's draw the structure. This is pentagonal bipyramidal geometry, XeF5, 1, 2, 3, 4, 5. All fluorines are placed in these positions, and all these positions are termed as equatorial. These are equatorial positions. Equatorial. Here two more positions are there. Their lone pair is present, axial, and this position is also marked as axial position. So in axial position, you can say what is the geometry? Its geometry, see, PBP, pentagonal bipyramidal, but in this case no atom is present, so it becomes pentagonal planar. Pentagonal planar geometry it is showing. So in case of XCF5 also, arrangement is exactly like this. Now let us take the exception of this rule, that is nothing but XCF6. So how XCF6 can be drawn? So exception of Bend's rule, you can draw here, that is XEF6. Exception of Bend's rule we are taking. So XEF6, how it can be drawn? We know that xenon 8, 6 fluorine plus 6, 14 divided by 2, 7. 7 means it is also sp3d3 and pentagonal bipyramidal geometry. Let's check its shape. What is going to be its shape? As one lone pair is there, in this case Xc, valency 8, 6 are occupied, 1 is vacant, means their lone pair is present. So it is going to show square pyramidal, or you can say distorted octahedral shape. Let's check XCF6. So in this case arrangement is in the same way, 1, 2, 3, 4, 5, 6, total 7. So 1, 2, 3, 4, 5, 6. So in this case lone pair is present. You can check here, there are 6 sigma bond and 1 lone pair, so 7 sp3d3. This is another way to find out the hybridization. Shape is known as distorted octahedral. This is distorted octahedral. Now, what is modified Bend's rule? Orbital occupying more space will have more percent as character with respect to the central atom. If you check here, in this case, you find out these angles and these angles in between them. So angular difference, axial positions, here we have seen that for axial position angle is 90 degree, but in this case it is 72 degree, and for equatorial positions angle in between them is 90 degree. So this is more space and this is less space, but in this case in axial position also one atom is present. So the rule that was signifying that percent S character will be more with respect to central atom, it is being violated. So this is considered as exception. This is the exception of Bend's rule. Exception of Bend's rule, we can say. Very good evening to all of you. Today we are going to discuss one of the most important concepts that students are confused with, known as Bend's rule and Drago's rule. Very less discussed topic in classes. So today we are going to take in detail about Bend's rule, how Bend's rule works and how it helps to decide the hybridization of a molecule. Hello, I am your chemistry educator. So today let's start with this topic. So for sp3 dehybridization, we calculate the forms and the structure by Bend's rule. What is told for sp3 dehybridization? So according to Bend's rule, more electronegative atom prefers to stay in the equatorial position. So more electronegative atom will prefer to stay at equatorial positions, whereas less electronegative atom or lone pairs prefer to stay at the axial position of the molecule. Now let's see. So what we can write, that more electronegative atom prefers to stay at equatorial position denoted as U, E, and less electronegative atom or lone pair prefers to stay at axial position. So why we are saying like this? Pause first. Going to discuss the recent amendments of Bend's rule. What are the recent amendments? We can say that the more electronegative elements not only prefer to stay in the orbitals having more percent p, in the orbitals having more percent p, but also it can have a more percent p character, but also it can have more percent p character orbital of central atom, attached orbital of central atom. So this is the recent amendments of Bend's rule. What is it? Means more electronegative atom that not only prefer to stay in the orbitals having more percent p. For example, sp3 we have taken. Here percent p is 75%. So it will not only prefer in the orbitals having more percent p, but also it can have more percent p character in its attached orbital with respect to the central atom. Now let's see for which elements it is applicable, for which elements it is not applicable. So first we are taking, it is not applicable for the compounds we can consider CH4, CF4, CCl4. It is not applicable for them, and it is applicable for CH2Cl2, CH2F2, CHCl3. You can consider CClF3. So these are the elements for which it is generally applicable. Now let's take 2-3 examples to understand what actually amendment signifies. वो ज़्यादा एग्जाम्पल देने से आसानी से समझ आएगा. एक बार देखिए, मान लो मैं CH2F2 का एग्जाम्पल लेता हूं. I am taking the example of CH2F2. How it can be arranged? It can be arranged like this: CH2F2. Let us consider this length is considered as alpha, this length considered as beta, and this length, FF length, considered as gamma. It is asked, compare the lengths, compare alpha, beta, gamma if they are respective bond lengths. How can we decide which has how much percent as percent P character? We know that fluorine is a electronegative atom. Fluorine is more electronegative atom. among all these elements present. So in this case we can say fluorine has more percent P character. What is the concept? That percent P character will be more, any element having more electronegativity. So it has more percent P. As fluorine has more percent P, as a result we can say that it has less percent S. If for this fluorine rule is applicable, for this fluorine also percent P is more and percent S is less. So what will happen for this hydrogen? Exactly opposite will happen. For this, percent S is more and percent P is less. Here also percent S is more and percent P is less. So if this is happening, we know that whenever percent S character increases, any group or element becomes bulky, means size increases, or if percent P increases for a molecule, then longevity, or you can say length increases. This is our basic logic to understand which of the lengths are going to be longer, which are going to be shorter. So in this case, alpha, beta, gamma, three lengths are there. Let's check. This is the length. Here P is highest, here P is highest. So in this case, we can consider that gamma length is highest. After that, beta, then alpha. We are taking few examples to understand this concept better. First example I am going to take CH3Cl and CF3Cl. What is going to happen in this case? Let's check. We are taking first CH3Cl. So in case of CH3Cl you can check carbon connected with 3 hydrogen atoms and here on chlorine is connected. Let us consider, we name this bond length as X, CCl bond length as X. We need to compare CCl bond length. Another is given CF3Cl. So carbon connected with fluorine, another fluorine and another fluorine, and here on Cl is connected. Now we are going to decide their character. Now in this case you can see that for this carbon and this Cl, chlorine is more electronegative. We know more electronegative has more percent P character. Perhaps you people are thinking that generally electronegative means S character is more. That is a different concept. If you are explaining with respect to recent amendments of Bell's rule, you need to decide this concept. So in this case, percent P is more and it is more electronegative, and percent S is less. For this carbon, opposite will happen. As a result, percent P is going to be less and percent S more. For this hydrogen and carbon you can consider. So in this case, percent S is more and percent P is less. Same thing we are going to check here. For carbon fluorine bond, fluorine more negative, percent P is more and percent S it is going to be less. Chlorine less electronegative in comparison to fluorine. So in this case, percent P is less and percent S is more. As a result, you can see for this carbon chlorine bond, percent P is more if we mark it as X, and this bond is as Y. So this bond is longer bond. So this is longer in comparison to the another case. Another example we are taking. Compare N bond length. If same type of element taken, I am taking N2H4 and N2F4. Let's check out. Nitrogen connected with another nitrogen and 2 hydrogens are connected over here. In N2F4, N connected to N and 4 fluorine atoms are there to be connected with the element. We are going to decide their character. In this case, nitrogen and hydrogen, you can say that nitrogen is more electronegative, so percent P is more, percent S is less. In this case also, percent S is more and percent P is less. Opposite happens. But in this case, fluorine is more electronegative, so fluorine's percent P more and percent S less. For nitrogen, percent S is more and percent P is less. As a result, here percent P is more in this bond, so this is a longer bond in comparison to N2F4. There is one mathematical derivation to explain that why we are considering axial positions only as more electronegative atoms place. How can we decide? And how can I decide that in sp3d, 3 equatorial positions are sp2, sp2 and sp2 and 2 axial positions are pd only? How can I decide? Let's check the mathematical derivation for this. So we know that let's check the mathematical derivation. Recent amendments of Bend's rule is a very effective method to decide percent S, percent P character as well as bond length of the element as well as strength of the element. More bond length means less bond strength. Now let's take the derivation. We know that cos theta equal to S by S minus 1. For S character, this is one rule. By percent S character we decide. Another format is cos theta equal to P minus 1 by P. If we take cos theta equal to S by S minus 1, as we have seen in this format, these angles are 120 degree, and for axial position, these are equatorial positions, angle is 90 degree. So we are going to take the value. We are taking cos 90. Cos theta here, theta value 90. So I can write cos 90 degree equal to S by S minus 1. It is 0. This value is 0. As a result, I can say that S value, if this is 0, 0 into this value, so S is going to be 0. So you can say that percent S character is 0%. In which position? In axial position. That's why I have considered these two as PD and PD. Now let's check for percent P, how much percent P is there. So in this case, if you take cos 120 degree, as this angle is 120, equal to that value, what can we write? S by S minus 1. So in this case, cos 120 value minus 1 by 2, S by S minus 1. From here what will come? 3S equal to 1, S equal to 1 by 3, that is percent S equal to 33.33%. You check these three positions, hybridization sp2, sp2 and sp2. In case of sp2, you can consider 1s, 2p, total 3. So 100 divided by 3 equal to 33.33. 33.33%, that is your percent S character. This derivation also proves that percent S character is 33.33%. That's why more electronegative elements are placed in axial position. That's why recent amendments of Bend's rule tells that if any element is more electronegative, their percent P character is more. So this is the concept of Bend's rule, modified Bend's rule and recent amendments of Bend's rule. We are going to discuss the last topic of today, that is Drago's rule. That is Drago's rule. So what is Drago's rule? Let's note down the rule first, then we'll discuss in detail. So it is, we consider that if an element belong to third period, we consider that if an element belongs to third period and electronegativity of side atom is 2.5. Electronegativity of side atom is 2.5 or less. Electronegativity of side atom is 2.5 or less, then there is no hybridization. There is no hybridization takes place in the molecule, or there is no hybridization takes place for the central atom. Now let's take the example in which of the following cases hybridization will not take place. We are taking group 15th and group 16th elements which are present in second, third, fourth and fifth period. With respect to that we are taking. So for group 15 element, what are group 15 elements? We consider NH3. For group 16 same is water. Nitrogen, after that phosphorus, PH3. Here which compound? H2S. Oxygen, then sulfur. Nitrogen, phosphorus, arsenic, antimony, bismuth, like that it goes on. So arsenic, antimony, SbH3. Here oxygen, sulfur, selenium and tellurium. You can see for NH3 hybridization is sp3. There is only one lone pair present for NH3 and it is available. Its angle comes near about 107 degree. Because for each lone pair angle decreased by, you can take this concept, for each lone pair bond angle decreased by 2.5 degree. So for sp3 we know angle is 109.5 degree approximately. If one lone pair comes, in that case it will be near about 107 degree. That happens for NH3. Whenever we are taking water molecule, here oxygen has two lone pairs. As a result, decrease in 5 degree from 109.5. So it will become 104.5 degree. It is its bond angle. But according to Drago's rule, how we can decide which is going to show hybridization, which is going to show different hybridization and which is not going to show hybridization? Let's check. In case of H2 also we can see sp3 hybridization. Here also we can see sp3 hybridization. What is the statement? Check properly. Element belongs to third period and electronegativity of side atom is 2.5 or less. In these cases it is going to happen. So from this to this they are not going to show hybridization. For them there is no hybridization. So no hybrid formation is there for these molecules. No hybridization is observed. Now you can check why PH3, SHH3, SbH3, these compounds are not going to show hybridization. What is the logic behind this? Let's discuss the logic properly. Let us consider I am taking PH3 molecule. PH3. My central atom is phosphorus. Phosphorus atomic number is 15. Now what is going to be its arrangement? Neon 10, 3s2, 3p3. Total 10 plus 2, 12 and 3, 15. You can check in case of s orbital in ground state it is filled. and p orbital is exactly half filled. You have 3 hydrogens. Each hydrogen is going to have s orbital. So all 3 hydrogens are perpendicular to this. All 3 hydrogens are going to connect with this. As these orbitals are exactly perpendicular to them, their bond angle will be exactly 90 degree or nearer, not appropriately 90 degree, nearby 90 degree. So if their bond angle is going to be nearby 90 degree and they are perpendicular to each other, in that case there is no chance of hybridization. We know that cos theta equal to s by s minus 1. If theta equal to 90 degree, percent s equal to 0. But here not exactly 90 degree, experimentally checked that it has approximately percent s character 2%. How many hydrogen is there? 3 hydrogen. So 2% into 3, total 6% s character is observed in pH3. So percent p character is approximately 94%. As percent p character is 94%, let us check in which structure it is possible. sp, sp2, sp3, all cases percent s character 50%, sp2 33.33%, and in case of sp3 it is 25%. So there is no case where percent s character is 94%. So basically hybridization of pH3, ASH3, SBH3, H2S, H2SE, H2TE is not possible. If bond angle are asked for pH3, in case of pH3, what are the elements? Nitrogen, phosphorus, arsenic, antimony. ASH3, SBH3, their angles are approximately 94 degree, 93 degree, 92 degree, near about that. So for these compounds, there is no chance of hybridization. By Drago's rule, we can decide the bond angle of the molecules. There is a very famous question that is regarding Cl2O and F2O. Which has more bond angle, it is asked. Let us check. Oxygen is the central atom and there are 2 chlorines. Here oxygen is the central atom, there are 2 fluorines. Size of the side atom, their electronegativity more than 2.5, their size is bigger. As a result, their bond length is more. If bond length increases, their bond angle will also increase. So Cl2O has more bond angle than F2O. F2O you are going to compare. Oxygen is more electronegative. As a result, electron cloud is towards oxygen. But here fluorine is more electronegative. As a result, electron cloud is moving towards fluorine. Electron cloud moving towards fluorine. So in this case, H2O as electron cloud for both the hydrogens is moving towards oxygen. It will face more repulsion. As it is facing more repulsion, its bond angle will increase. It is facing less repulsion because the lone pairs is being distributed to 2 fluorines. As a result, bond angle of H2O is greater than F2O. So if we consider all 3 elements together, Cl2O highest bond angle if we are comparing bond angle. After that H2O, then comes F2O. Very, very important questions, and this is asked in many exams. Bond angle proportional to 1 by lone pair. If number of lone pair increases, then bond angle will decrease. It is proportional to electronegativity and it is also proportional to size of side atoms. With respect to this, let us take last 3 questions of today. First we are taking SOF2, SOCl2, SOBr2 and SOI2. Which is having bigger size? SOI2. Iodine having bigger size. So order of bond angle is this. If you take PF3, you take PCl3 and PBr3. This is going to be the order. PI3 you want to take, you can take. For Pi3, this is going to be the order. Let us consider you take NO2 plus, NO2 dot and NO2 minus. For that, what is going to be the bond angle? For NO2 plus, nitrogen 5 plus charge is there, 5 minus 1, 4 divided by 2, 2. So hybridization is sp. It has highest bond angle near about 180 degree. So uncomparable with respect to both. In this case, nitrogen atomic number 5, 5 plus 1, 6, 6 by 2. This is sp2. This is also 5 by 2. Its hybridization also considered near about 6 by 2. This is also sp2. When one single electron is there, we take one more. So sp2, this is also sp2. Now how can I compare the bond angle in between them? So to compare the bond angle in between them, here minus charge is there. We know whenever minus charge is present, minus charge comes with one lone pair. So here lone pair is also present. As a result, here lone pair bond pair repulsion will be observed. So in this case, we can consider that NO2 plus having highest bond angle, as repulsion is more, in that case bond angle will decrease. As a result, next will come NO2 dot, after that NO2 minus. In this way we can decide bond angle of the molecules. I hope you understand both the concepts of Bend's rule and Drago's rule. Please read it properly and apply in many questions. It will help you to solve the questions. I hope you enjoyed the lecture. So be with me. Let's learn and help people to learn. Thank you everyone. Be connected.